If you already have containerized application on the top of Kubernetes, it's hard for you to compromise with your existing monitoring environment. And you will definitely need a Kubernetes-friendly system. Hi, this is Kisung from Virginius. Today, we are going to talk about the Kubernetes monitoring using Prometheus. After this video, you'll be able to know the basic concept of Prometheus and how to deploy in your Kubernetes environment. Before we jump into it, let's talk about why monitoring is important. Monitoring is one of the key pillars in order to move forward to the cloud-native approach. In highly distributed system, it's fairly hard to forecast the expected behavior. Here we have 4 objectives to monitor your system. First is for knowing the trend. The best way to forecast what will happen in the future is learning from the past. Second, the accumulated data is powerful. For example, you're running a food market online store, and let's say there are 1,000 people logging into the website and you need 50 servers to accept them. How about 10,000? You already know the answer. Third, alert. If something is broken, somebody needs to fix it right now to reduce SLA. Last but not least, the best way to see how your system is running is to make a dashboard. There is a word called 4 golden signals, which gives you simple ideas of how to make your system healthier and maintain with high performance. I highly recommend going to the link to see what the 4 golden signals are. So in conclusion, monitoring is made for achieving the trend, comparison, alert, and visualization. Well, how do you achieve this? We have a monitoring system called Prometheus, which is the most popular monitoring tool in the open source ecosystem. Prometheus was created at a company called SoundCloud in 2012, and now it was contributed to the CNCF in May 2016. In terms of feature, Prometheus has a lot of capabilities when it comes to monitoring, but I'd like to highlight on the 3 pillars what it has, which is time series data, integrations, and 3 combinations of scoring, alerting, and the dashboarding. Let's look into the diagram to see what components of Prometheus has into it. First is Prometheus Server. Prometheus Server is the heart of everything. It knows where the things that you care about, and we call this target. But how does the Prometheus know where the targets are? That's when the service discovery and exporters come into play. Specifically in Kubernetes, the service discovery talks to the Kubernetes API server, and it will detect what needs to be collected using labels and annotations. So here, your target either can be some microservice application or the Kubernetes components itself. When it comes to your application, if you define your target to the Prometheus, it will talk to each services and start collecting them. In order to monitor the Kubernetes itself, we need to monitor Kubernetes nodes and kubesystem components. We have things called exporters. These little things can do translations of original data into metrics format so the Prometheus can understand. We have 2 main exporters called node exporters and kubestate metrics. The node exporters talk to system kernel and bring the machine code and translate to the Prometheus format. And we also have kubestate metrics, also known as KSM. The KSM will directly talk to the Kubernetes API server and generate the state of the object. This includes the metrics such as pod, deployment, stateful set, and most of the components in kubesystem. So, we now have metrics. The Prometheus server will store the data, and then you can push the metrics either for visualizing it using the dashboard with an application called Grafana, or you can calculate the metrics based on the threshold you defined, and once the alert is triggered, this will be sent to the alert manager and it will aggregate, route, and dispatch to the email, Slack, and so on. So this is the whole stories of how the metrics are collected and turned into the meaningful data. And it's also known that Prometheus have a great match with Kubernetes. This is because Kubernetes has its own unique challenges in the monitoring system. Let's find out how the Prometheus can solve that. First, Prometheus can collect nearly all metrics in the Kubernetes. In the traditional applications, the layers that you should care about is pretty simple. You install the OS on the hardware and then run the application, and that's it. Whereas in the container world, we now have to care about the orchestration layers and the multiple containers. The good news is that the Prometheus can serve nearly all metrics across all layers. Second, we haven't talked about the service discovery. If your application supports HTTP-based connections, you can easily define the endpoint of services by using the labels and annotations, and the Prometheus will serve that for you. Also, in case of using the exporters such as node exporters and kubectl metrics, Prometheus will detect them automatically and do the rest of the job for you. Third, pulling metrics. There are two ways of collecting metrics, which are push and pull methods. The main difference is who is the object which triggers gathering metrics. If the application pushes their metrics to the monitoring system, it's called pushing the metrics. On the other hand, if the monitoring system requires to the target to collect the metrics, it's called pulling the metrics. Those two types both have pros and cons. However, if you solely think about microservice environment, you will see that from the architectures, it will require less network traffic, and also when the number of the application is increasing, you don't have to configure the endpoint and the Prometheus will scrap the metrics from them automatically. So it's better for aggregation. And how do you do if there is a need for pushing the metrics? We have a component called push gateway, and the push gateway will serve the pushed metrics, and the Prometheus will pull them from the gateway. We now understand what the Prometheus is and what it does. From now, we will install the Prometheus on the top of Kubernetes. You can manually install all the components for better understanding, but I would recommend leveraging the Kubernetes native deployment, and this project is called Prometheus Operator. The purpose of this project is to simplify and automate the configurations of a Prometheus-based monitoring stacks. Helm is widely known for package management for application YAML file. We can also leverage the Helm when deploying the Prometheus Operator. We will just use the manifest file from the Prometheus Operator repository and deploy them with several commands. In order to install the monitoring stack, we only need 4 commands. After cloning the repository by using the git command, you will deploy the basic setups and the main manifest file. And that's it. End of installations.